Everything you need to know and learn about the reactivity series and displacement reactions. Roll the graphic. Hello, welcome back to Science That Sticks. I'm Paul, and today we're going to look at the reactivity series. The reactivity series is a group of elements, mostly metal, two non-metals, in order of reactivity. Now, they are in order of reactivity with whether they react with water, whether they react with one another, or whether they react with carbon or not with carbon. How do we go about remembering them? Well, there's a trick that I use. The trick is this. I put a letter and a different word for each of those, and then I move that letter to a metal that I know. So, let's go with, please stop calling me a calm zebra. Instead, try learning Harry's correct surnames, gold, platinum. We don't know who Harry is, it doesn't matter. But because I wrote that sentence out a few times and I've just got the initials, well, this is pretty easy stuff, because one of the things I now can do is I've got my letters in order, I just need the metals. So, potassium, sodium, calcium, magnesium, aluminium, carbon, zinc. Please stop calling me a calm zebra. Next set. Instead, try learning Harry's correct surnames, gold, platinum. Iron, tin, lead, hydrogen, copper, silver, gold, platinum. It's really easy. Really, really easy. Once you keep doing this, you will find that you can use this method to remember all sorts of things in order. Now let's put in the actual elements themselves. Okay? How do we use them? Well, if you want to know if it will react with carbon, everything below carbon will react with it. So if you've got zinc oxide, you can add it to carbon and you can heat it up and you'll make carbon dioxide and you'll have the pure metal. Silver, gold, platinum don't exist in nature as oxides because they're unreactive. They're very unreactive. So you can find them right out the ground. But iron, tin, lead, copper, you can react with their oxides or their sulfides with carbon, and the carbon will displace those other non-metals and you'll end up with the pure metal. Now if the reactivity series is above hydrogen, then that means it will react with acid or with the water. Pretty easy stuff. Everything below hydrogen will not react with water and it won't react with an acid. Easy stuff. Let's go for some examples. So the first example I'm giving here is if you react magnesium with copper sulfate. Now we're going to put, well, we're not going to do it, but you can see, and your teachers will often do this, a piece of magnesium will go into an aqueous solution of copper sulfate. You give it a few minutes, the magnesium, which is more reactive than the copper, will displace it. In other words, it will push it out, making magnesium sulfate and copper. There will be a colour change, so it will go from blue. Often the magnesium will turn black, or it will appear black. It actually will get coated with a fine layer of copper. The chemical equation looks like this. Because you've got a solid at the start, that's what you've put in to the solution. It will react, it will displace it, and you will get copper. And because copper is a solid, it doesn't dissolve, you will actually start to see a colour change. That's it, it's really easy. Now let's look at a second example. Let's look at some halogen displacement reactions. They're not difficult, they're really not. You have to remember that if you've got a metal halide salt and you're going to react it with a halogen. If the halogen is more reactive than the halide in the salt, there will be a displacement reaction. Similarly to the metals that you've just seen. Let's check one out. Now in this case, what I've done is I've stated that potassium bromide is dissolved in water. That's an aqueous solution. And what you are potentially doing is bubbling some chlorine through it. That chlorine gas will displace the bromide ions, pushing them out to become bromine, which will be bromine liquid. In this case, you'll actually see a colour change. It will go from clear and colourless to being slightly orange because you're making bromine. It will probably react with the water as well as it happens, so you'll end up making a bit of bromine water, but the reaction is still good. Now, if we change this to potassium chloride dissolved in water, it's not going to happen. No reaction, because they are the same reactivities. Dead easy. That's it. Until next time, as always, stay cool. Bye for now.